All right. So up to this point, we have seen that we can draw electric field vectors in the region of space around some charges, but the process of doing that is pretty laborious and it's pretty messy. Okay, so what we'd like to do is improve that process if we can. So drawing electric field vectors is laborious and messy. Okay, so laborious because we have to consider the direction and the magnitude for each part and then use superposition. Messy because, again, superposition is a little bit messy, and also there can be some overlap between vectors. Okay, so another approach that we can use to represent the same information but in a slightly different way is electric field lines. Okay, so electric field lines represent the electric field a little more elegantly. Okay, and you'll see that this is a little bit easier and a little bit gives you a little bit nicer result. Okay, so first, what are the rules for electric field lines? All right, so electric field lines start on positive charges. Or at infinity. Okay, so we'll see how you can tell which is which. But if there are positive charges, that's where the electric field lines start. The electric field lines end on negative charges. Or, again, at infinity. The direction of the electric field is tangent to the field lines, and the strength of the electric field corresponds to the line density. Okay, so where the lines are close together, the field is strong. Where the lines are further apart, the field is weak. Okay, so I think the easiest way to understand this will just be to do some examples. So let's start out with a positive charge. Okay, so the positive charge, like this, is going to have some electric field lines. We know electric field lines start on positive charges, and then they end at negative charges or at infinity. Well, here we don't have any negative charges, so they're all just going to extend outward to infinity. Okay, the exact number we draw is kind of up to us. I'll draw 8. Okay, so electric field lines starting at the positive charge, going off to infinity, like so. Okay, they have arrows that tell us the direction, and then the direction of the electric field at any given point is going to be tangent. So if I pick some spot here, the electric field will point away. If I draw an electric field vector here, it'll point away. Okay, so just along the lines. As for strength, well, if we look near the charge, we can see that the lines are close together, and then further away, the lines are further apart. So that tells us that the strength of the electric field is strong near the charge and weak further away. Okay, so this took approximately 15 seconds to draw the electric field, and it's a lot nicer, cleaner representation than what we had when we drew electric field vectors. You still get the sense of that structure where the field is strong nearby, weak further away, always pointing away from the charge that we got from the electric field vectors, but this is a lot simpler way to show it. All right, so I suggest that you pause the video and try drawing the electric field lines for the negative charge instead. Okay, so go ahead and give that one a go. Okay, hopefully you did that. And then what the electric field line will look like here is just pointing towards the electric field vector. This time they start at infinity because there are no positive charges handy. You could draw 4 lines if you want. If you want to draw some other number just to match the other one, you could draw 8. That would be fine. But what you want to see is that all the field lines end on the negative charge and point straight inwards from infinity. Okay, so at this point it may not be clear how much better this is, but I think when we do an example with 2 charges, you'll see how much this cleans up the process. Okay, so for this example, let's say that we have a positive charge here and a negative charge here. Okay, so this time we can have the field lines start on the positive charge and end on the negative charge because both are present. So I'll just do that. I'll have the first electric field line go there. Do one here. Starting at positive, ending at negative. Like this. Okay, and then the others will kind of go out like this. Maybe one going like that. Okay, and then over here, I'll have them coming in like that. All right, so that was it. That was how long it takes to draw the electric field diagram for these 2 charges. Again, I think you'll see much faster than what we had before. All right, and then some of the things that we can notice from this is now we can see why the electric field up here points to the right and down here points to the right. That just has to do with the symmetry of the situation, and that's the direction tangent to the electric field lines. We can also see that the field is stronger right in the middle because that's where the field lines are closer together. For these lines that we see over here, you might think that those are going out to infinity, but in reality, those lines actually loop around to these. So we just get bigger and bigger loops, and that also kind of tells you something interesting about the structure of the electric field. If we have equal amounts of positive and negative charge, then all the field lines should start on the positive charges and end on the negative charges. For the ones that happen to go exactly to the left in this case, maybe those go to infinity, but that would just be exactly one line. All the other lines are going to form these loops. So some of the benefits of this of drawing electric field lines rather than electric field vectors is that it's really fast, as you can see. It didn't take us nearly as long to do. And also, in some ways, this gives us a much cleaner picture. Okay, so instead of having all the superposition arrows, instead of having arrows cross each other and so on, here we just get this picture of what the overall structure looks like. And then finally, like I was saying, this gives you a nice big picture. So you don't have to keep drawing an infinite number of vectors. You can just draw a few field lines and then kind of estimate what the rest will look like. There are some drawbacks, though. The main one is that it's not as precise. Okay, so if you really wanted to do a quantitative calculation, then this would not be the way to go. But if what you wanted was to understand the overall structure, if you wanted to know, is there a place where the electric field points straight upward, for instance, or if you wanted to know, where is the field really weak, where is it really strong, this picture might give you a, nicer way to see that. Okay, so I suggest, again, that as more practice, you try drawing the electric fields with 2 positive charges. Okay, so go ahead and give that a try.